So last week I covered more or less the foundations of regex for security, some of the more common mistakes that can happen, how regex works, and one example from Ruby that could actually have led to RCE with regex. But today I want to look at some actual write-ups from some bug bounty hunters who have looked at these regex vulnerabilities and identified where their weaknesses are. So in the way that the developer writes them and some of the assumptions that they made. This is obviously a natural progression. We're going to start looking at real write-ups to see how these vulnerabilities are going to exist in the real world, which is sometimes different than the theoretical stuff we do today. So the first vulnerability is going to be a blind SSRF. The second one is going to be an OAuth vulnerability, and the last one is going to be a general XSS write-up with weak regexes actually in HTML validators. So some pretty cool reports, and we'll jump straight into them now. So the first report is from this weird Go library, and it's just a basic simple blind SSRF. I wanted to start with something not that difficult so that we can understand basically what this is going to look like. And it allowed us to basically hit internal services, but it was a blind request and it was a blind get request, so it wasn't really that impactful, but we can still have a look and see where the regex went wrong. This is one of the functions here that used some of the regexes here to basically make a check, and the regex looked like this. So you see the regex pattern here, and if you remember from my last video on covering the basics of regex, you should definitely go watch it, by the way. There's a lot of common foot trips here with the regexes, and some of these characters aren't literal characters, but they actually mean something different in regex. So if we just follow along with what's going on here, then the regex starts with HTTPS / there's some domain, so this looks like Amazon EKS domain, so some kind of cluster, Kubernetes cluster or whatever. Then we have like any number of characters, lowercase, hyphens are allowed, underscores are allowed, characters A to Z, uppercase and lowercase, and numbers at least once, but can be any amount of times. And then Amazon AWS.com, and then this path ID, and basically the same thing again, just this time for the path. So what this regex is doing is pinning the URL parameter, suppose it's some URL parameter or whatever, down to a specific domain with some kind of wildcard in the middle of it, basically, followed by a path, a specific path on that domain, and then pinned down to only basically ID. So you can't go any other paths apart from that. Now, can you spot the issue? Well, the issue is that it hasn't been anchored. So anchoring in regex is where we put either one of these characters, so this arrow character or this $sign character, that will tell regex that this should only be matched at the start of the string. If this is not there, then literally any part of the string will match it correctly. And in this case, the attacker was able to match it with something like this, because regex matches anywhere in the string unless you tell it to. It'll match any part of the substring, which is what it's designed to do, and it will return it to you exactly as you want it to. And this can lead to a lot of problems, and obviously this led to this validator being bypassed. So there was a SSR vulnerability here because the regex was bypassed. That was pretty cool. And yeah, basically in this service it led to blind SSR. Now this is only like a get, and it also was blind, so there was no way to read arbitrary responses or whatever. But either way, it's still a cool vulnerability and shows you just how easy it is by forgetting one character to basically mess up your regex. The next report is in this thing called Authentic, which I think is like an identity provider as far as I know. Well, anyway, they have like an OAuth 2 system, as literally every app nowadays does. So you can register an app and sign up or whatever. And the researcher goes into what OAuth 2 is. I assume you have some kind of understanding of it, but basically if you don't, the crash course is one of the apps registers, that you get a link back and then you approve it, and then a code gets sent back to the app, and the app can exchange the code with the resource provider for your token. If that didn't cover it for you, then here's a diagram for you basically. So you get a link, you go back, then the app exchanges, you get token back, and now the app can access your data. And the vulnerability was here basically. So when you're typing in these redirect URLs, on some websites you can use regex with it, right? So on some websites you can use regex with it, and you can type in like a regex pattern, because in some cases you might need to allow wildcard origins for your redirect URLs. Basically, the main vulnerabilities around OAuth are attacking this redirect URI, because it kind of leads to these like phishing scenarios where basically you entice someone to click on a link where the redirect URI is something that you control. They like authorize your app on like, you know, a legitimate looking page controlled by the main application, but the code gets sent back to you. So that's like the main attack surface for auth. And when this redirect URL is parsed incorrectly, that can lead to some pretty severe vulnerabilities, at least in the eyes of the program managers. So they were using this really annoying Python code. They were using Python code, and they were using full match. So they were allowed regex basically in this pattern. But what this researcher noticed is that most apps forgot to escape the dot on the regex pattern. So most people just didn't even know that this was using regex, and they literally just put down like a whole application here and put the dots in. So if you know about regex, the dots are any character, right? Dots can be any character. So that can lead to, as they documented, stuff like this, where an attacker could register a domain and put any character except a dot, like an A or whatever, be 0 in this case, and it would still match the regex pattern. So that's where the code would get sent to at the end. And they framed this as the vulnerability. Now they call this intended functionality apparently, because that's just classic code that they always do. But then he actually found out that like the provider program was like using, they had like a cloud platform that was using like this service authentic on the back end. And then, and then it turns out that they actually made this mistake. And I think they had like a pretty cool video here, I'll show it to you here, that they actually like literally made the exact same mistake, where he was able to register a domain with a dot inside of it, like an unescaped regex pattern. And then once he went to it, he ended up being able to basically take the session ID from it. And I think as well, because he was able to log in, and then basically the session cookie went into his thing, and he had the CSRF token as well. So I think that's pretty funny, and and it turns out that they changed their mind after that. So I think that does show you that you have to be careful with regex, definitely, because if you don't tell people that this feature is using regex, they're going to make mistakes. And I would definitely wouldn't trust users with building good regex, because it's hard enough to do it as an app maintainer. Trusting users to do that seems like a pretty bad idea. So I think the fix was they just escape these things automatically now for you, and it's just probably better that way, to be honest. And so those are the kind of things that can happen with these redirect URIs, especially with OAuth. So keep an eye out for these unescaped regex patterns. This was obviously a white box analysis, so he had the source code here. That's not what is always going to happen, but if you register like an app on an OAuth provider, check if the regex, maybe there's like a regex pattern doing it, maybe the dots aren't escaped. So it's something worth having a look for as well. And the next report is covering a kind of different class of regex. The stuff we're looking at is more server-side stuff, but now we're going to have a look at client-side regex. And a lot of it is used actually to sanitize HTML, which is, kind of what it's actually supposed to do. It's good for finding substrings in HTML elements. So if you want to find an element outside of it, regex is pretty good for that. And a lot of the sanitizers rely heavily on using correct regex. Now, correct, it sometimes can actually backfire on us. And in different situations, in a perfect world, the regex will always work. But especially when you're dealing with attacker input, where the attacker can craft these weird payloads with like embedded attributes and stuff, it can lead to some vulnerabilities. And I think this is a pretty cool write-up from this user here. All the write-ups will be in the description, by the way. I recommend you have a read of them yourself, because I'm just kind of giving you a gloss over them. As you can see, they have this regex pattern here. So they've created the regex pattern that's supposed to filter an attribute. Say this is like an on-click attribute or something. And basically this is put straight into the regex. And what this will do is this will find the attribute name equals, and then say like find these things in apostrophes, right? Obviously there's a lot of issues with these kind of things, like browsers will render stuff very differently. Sometimes you don't actually need the commas for the script to execute. So like if this was like a JavaScript URL, it would execute anyway. And the problem is also this greedy matching, which the person will go into. So what this inside of this regex does is the dot, any character, the asterisk character, it will match basically from 0 to an infinite amount of times, as many times as physically possible. And the question mark for, you remember, that's like the optional character. I call it like optional, but it actually does something very specific, which is it will make it match from like 0 times to 1 time. So it'll make it what's called lazy matching. There's 2 types of matching in regex. There's greedy matching and lazy matching. So greedy is as many times as physically possible. Lazy matching is the least amount of times as possible. So that basically is what switches it. And it's what prevents the regex from consuming the comma after the question mark. That basically is because it'll stop consuming it as soon as possible. Instead, if that wasn't there, it would consume the comma and just keep going forever, basically, because the dot asterisk is unbounded. And we have a look at something like this, for example. They showed the regex working, it goes down. But then, you have these situations where the regex pattern, it's not a perfect world anymore. The attacker can tailor different kind of things. And, they showed here, for example, that this was inside of an actual tag itself, which means that the regex would eat this like comma, and then it would continue to the next one, which happened to be here. So it actually consumed the entire tag. And this is because the regex didn't factor in that the actual attribute name could have been inside another tag that the attacker controls. So that is super interesting. And that's how that can lead to like a JavaScript vulnerability like this, for example. And, it can also be, for example, inside of another tag like so. So it can be here, and then it can, end up being consumed. So it's just kind of a difference of where the developer kind of thought the attribute would be versus where the attribute actually can be, and the certain like regex kind of manipulations you can do there. And yeah, there's different kind of things to see, but this is a very cool example of how regex can kind of go wrong, especially with XSS vulnerabilities. And I really recommend that you read this right up. And yeah, by the way, if you do enjoy my content, then you might want to have a look in the description at my community. It's a program that will give you access to my community where you can, chat with me and all the people in there, as well as get access to some of my labs, some of the interactive labs that I've built, specifically focused on the server-side vulnerabilities and some client-side ones that I've personally modeled, backed by, some of the research that I do basically every day. And I think it's a very cool product. So if you do enjoy my videos, then it's a good chance you'll also enjoy it. So check out the link in the description. Hope you enjoyed this video covering some of the write-ups around regex. It's, something that I'm working on as well now. I'm sharing it with you guys. I've been doing it for a few years now, and I think I have a bit of experience now. All the articles are going to be in the description, so go have a read of it. And I also encourage you to practice regex yourself if you want to get good at identifying it. Writing simple regex with the tool I showed you previously, it's called Regex 101, will actually, I think, really start leveling up your skills in it and allow you to spot situations, make you more conscious of situations where regex has been built incorrectly, where we can deliver specifically crafted input that will bypass the regex that is being used. And that is a very important skill, is, being able to identify, kind of like unit tests in programming. If you're not familiar, unit testing is like when you have a function, you isolate it, and then you put a load of different inputs into it to see how it kind of reacts. And that's kind of the same thing we want to do with regex. So we want to take the bit of regex, we want to think about, what kind of inputs can we put in here, almost like brainstorming, and just fire them out and see, like, what does it do when this happens? What if, it's inside the attribute? What if it's like, these type of things? And I think that's a very cool practice that you can honestly do yourself as well. That's it for me. Thanks for watching, and happy hunting.